In this video, we're given that the cosine of theta is equal to 1/4, and theta is in quadrant 4. And that simply means that the terminal side lies in quadrant 4. Find the exact value of sine of theta, and for number 2, the tangent of theta minus pi over 4. Now, I want to remind you to make sure that you know your basic identities. When you prove or verify certain identities, you're going to be using these basic identities. When you solve equations, you'll be using basic identities and, in some cases, more advanced identities. But here are the most fundamental ones. For tangent, sine over cosine, cotangent, cosine over sine of the angle, of course. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine. It can work the other way around also. Cosine would be 1 over secant. Sine would be 1 over cosecant. Cotangent is 1 over tangent, or tangent is 1 over cotangent. Then you have your Pythagorean identities. Similarity to a squared plus b squared equals c squared for your right triangle. Even odd identities. Sine of minus theta is equal to minus sine of theta. Cosine of minus theta is equal to cosine of theta. Tangent of minus theta is equal to minus tangent of theta. Now, if you evaluate a trig function at minus theta and get the same thing back, it's called an even function. So cosine and secant are even. If you get the opposite, like sine of minus theta is equal to minus sine of theta, same thing for the cosecant, same thing for the tangent and the cotangent, and those are odd. So the only trig functions that are even are cosine and secant, and the others are odd. That also implies that if you have an even function, the graph will have symmetry with respect to the y-axis. If it's odd, it'll be symmetric to the origin. And then you have your sum and difference identities, or formulas. You have one for cosine of a plus b there, and cosine of minus ab. Notice the similarity here. The only difference on the right side is the first one's minus, second one's plus. For sine of a plus b, sine of a minus b, again, notice the only difference on the right side. Over here on the left is plus, on the right is minus. And then for tangent of a plus b, again, difference in signs, tangent of a plus tangent of b over 1 minus tangent of a, tangent of b. And for the difference, tangent of a minus b is tangent of a minus tangent of b. And then it's 1 plus tangent of a, tangent of b. Now for this problem that we're going to look at, or one of the problems we'll look at, we'll be using this last one here. Tangent of a minus b is equal to tangent of a minus tangent of b over 1 plus tangent of a, tangent of b. So let's look at the problem here. We're given cosine of an angle theta is equal to 1/4. The angle is in quadrant 4. And again, that means that the terminal side is in quadrant 4. So the angle goes like this. So we take this as our reference angle. And you should know that if an angle has a terminal side in the first quadrant, here, doesn't matter how many revolutions it makes, as long as its terminal side is in the first quadrant, all the trig functions will be positive. Over here in the second quadrant, the sign will be positive. Over here in the third quadrant, sign will be negative. Same thing if it's in the fourth quadrant. So we're going to use a reference triangle here. Cosine of the angle is 1/4. Cosine is 1 over the hypotenuse, so I'll label it this way. And we know that the sum of the squares of the two sides is equal to the square of the hypotenuse. So this side right here then should be the square root. Square of that is 16. This square root of 1, subtract it, and this should be square root of 15. Check it out. This squared is 16. This squared is 15. This squared is 1. Add them up, and we get 16 is 16. So the sine of theta, if I look at the triangle, opposite square root of 15 over the hypotenuse, which is 4. Remember, the angle terminates in quadrant 4. So in quadrant 4, the sign is negative. So keep in mind that if you have an angle in standard position, that simply means that the initial side right here coincides with the x-axis, and then the terminal side, or ends up, will determine whether it's going to be a negative angle or a positive angle, because we know that if you take any point on that terminal side, say xy, the length here from the origin to that terminal point right there, let's call that r. Then the sine, using the angle in standard position and at any point on the terminal side, and in this case we're looking at sine, it's going to be the y value, whatever it is, over the r value. R is the length from the origin to that terminal point right there. So r is always positive. So you can see in the second quadrant, the y's positive. But see, we're talking about this angle here in the fourth quadrant. Always use the reference angle, this angle. Or in this case, if it terminates over here, this angle right there, that'll be theta. That's how I get this triangle here. So now in this case, if I find a point on the terminal side, the x value is positive. Because it's below the x-axis, the y value is negative. You're talking about a negative y over a positive r. That's why we get a negative. If it had said that the angle was in quadrant 1 or quadrant 2, this would have been positive. Quadrant 3 still would have been negative. Okay. Now, for number 2, we want to find the tangent of that same angle, theta, minus pi over 4. So here's where I'm going to use the identity I just mentioned. So if I have the tangent, in this case, the difference of two angles, it was the tangent of the first angle, in this case theta, minus the tangent of the second angle, pi over 4. And then that was over 1 plus the product of tangent of the first angle theta and the second angle pi over 4. So it'd be tangent of theta times tangent pi over 4. So the tangent of the difference of two angles is the tangent of the first angle, in this case theta, minus the tangent of the second angle, pi over 4, over 1 plus the tangent again of the first angle, theta, times the tangent of the second angle, pi over 4. And then we go ahead and simplify. So this is going to give us tangent of theta. That stays the same. Tangent of pi over 4 then, that's the same thing as 45 degrees. So you should know that the tangent of that is 1. And then tangent of theta here, I'm going to reverse these. So tangent of theta, of course, is tangent of theta. Tangent of pi over 4 is 1. So I'm going to rewrite it this way. Tangent of theta plus 1. Now, from the triangle, and tangent of theta, that's going to be minus 1. Denominator, the same thing. Tangent of theta plus 1. But let's refer to the diagram over here. The angle terminates. Remember, this is the reference angle right here. But the main angle we're looking at, theta, is over here. And the tangent of that angle is y over x. So it's a negative over a positive will be a negative. So from the triangle over here, the tangent, again, we're using the reference angle, is for tangent opposite over adjacent. So that'll be the square root of 15 over 1 is the square root of 15. But remember, it's in quadrant 4. So it's a minus over a plus is negative. So this will give us negative. Instead of the square root of 15, it's going to be negative square root of 15 minus 1. In the denominator, same thing. Square root of 15 minus the square root of 15 plus 1. And then I'm just going to multiply here by a negative 1. So it'll be the square root of 15 plus 1 for the numerator. And for the denominator, it'll be the square root of 15 minus 1. And now I'm going to rationalize this by multiplying by the conjugate of what I have in the denominator. So this will be the square root of 15 plus 1. Square root of 15 plus 1. That's the conjugate. So in the denominator, I have the difference and the sum of the same two terms. Square root of 15 minus 1 times the square root of 15 plus 1 That'll just give me square root of 15 squared minus 1 squared. That'll be 15 minus 1. This will give me a 14. Numerator, I have the same product, the same factor, square root of 15 plus 1, square root of 15 plus 1. So that just gives me the square of the first, which is 15, plus twice the product here. Give me 2 square root of 15. And then 1 times 1 is 1, so it'll be a plus 1 here. Let's just add it to the 15, so this becomes a 16. So we got 16 plus 2 square root of 15. And then just reduce it. Take out a factor of 2 here. It'll be 8 plus the square root of 15. And then 2 into 14 is 7. So we just reduced it. So you can say we divided the numerator by 2, the denominator by 2. So the exact answer is 8 plus the square root of 15 over 7. So that's going to be it for the video. Just a reminder to know your basic identity. If you're just starting off your trig course, there's going to be plenty more of the more difficult identities. And if you're taking calculus 1 or calculus 2, you'll see these again in solving problems in those areas. Thanks for watching. We'll see you next time.